just
did that.
you. It's not just you. I'm feeling the same way. But I'm not trying to be negative, I'm trying to be positive. Hey, here's some good news. We are going to learn our last new way to solve for quadratic solutions, okay? So today, this lesson is called the quadratic formula. Maybe you guys have seen this before. Maybe you've heard of it before. Maybe not. Maybe it's totally new. Probably new to you. I'm not sure. Anyways, um, our goal, learn and use the quadratic formula to solve quadratic equations. It's our last new way. So all of this unit has been like different ways to find the two solutions, right? X is this number, X is that number for some quadratic that we start with. So we're given these equations, the quadratics, and then we have to use one of our methods to solve for the solutions. Um, and this is our last one. So there's a benefit to this quadratic formula, and that's that it takes us straight to the answer. We don't have to do any lists. We don't have to do any factoring. There's zero factoring to do if you want to use the quadratic formula. So in a way, it's a little more direct.
Wait, just like, I think I missed the formula. I'm sorry.
Oh no, I didn't do it yet. I was going to do it right now.
Okay, okay, sorry. Go
No,
ahead.
don't be sorry. It's all good. It's all good. Here comes Manaya. Here we go. All right. So here we go. I think the only way, the best way that I want to just do this with you guys today is just to show you the formula and then do some examples and get right to it. There's not much else to really talk about. So I won't talk all day, hopefully. So here we go. Here's the actual formula. If you forget it, have it written down because it's going to take some time to start to remember it. All right, here we go. And remember, we're using the A, B, and C from our quadratic. So hopefully you've all remembered that by now. The A, B, C, we know where those are coming from. So here it is, negative B plus minus, there it is again, plus minus, the square root, make it a big long square root like mine. And inside the square root box, we've got b to the second power minus 4 times a times c. And then the whole thing that we have there, negative b plus minus the square root box, that whole thing is being divided like this, divided by 2 times a. Copy this down. We're going to use this today. And frankly, when you're taking a mastery test, when you're taking a post test, and it's telling you to uh, solve for X, right? Solve for the solutions. The test doesn't know, folks, if you're doing it by factoring, if you're doing it with completing the square like we did yesterday, if you're doing it with the quadratic formula. My point is, you can pick the way you like to solve these. I want you to be armed with the knowledge of all of the different methods. I want you to be ready so you can use any method, right? And that's why I'm teaching all these different ways. Um, I want you to be able to use them all. However, if you're taking a test with me, or if you're taking a test at another school or college later, um, unless you're doing it on paper and you're turning in the work, which, that's good too. The test doesn't know which method you're using. So you can use any of these methods. I want you to have this written down so you can practice it with me today. But then later on your mastery tests and your post test, you can use any method that works best for you, that you prefer. There's one thing I forgot from the quadratic formula, and it's this. The whole thing that I've written is equal to x, our solution. So x is equal to the entire formula, negative b. plus minus square root of b squared minus 4 times a times c, all divided by 2a. So when we plug in our a, b's, and c's from the quadratic given to us, we're going to simplify this mess, okay, this messy formula. Simplify it down one step at a time, and at the end, you'll have your two solutions. So just in case, I'm going to add this at the bottom, just in case you're feeling iffy or confused on what is A, B, and C. Remember, we're getting A, B, and C from, so use A, B, and C from your quadratic, this form, the standard form, which is, I usually do capitals, but I've written them here as lowercase. So just remember, it's ax squared plus bx plus c equals 0. Make sure you're solving it for 0 to start with. So if you've got if you have a quadratic and it's equal to 14 or equal to 25, we want to bring that 14 or 25 over to the other side first. Subtract it over. Make it go combine with C. And we'll see an example or two like that in just a minute. Any questions before we start our first example? Comments? Okay. I'm going to move on. Does anyone need to keep this screen up for another moment?
Wait, actually, so when you're talking about the use A, B, and C from the is that like the problem before this step?
Basically, yeah. Yes, sir.
Okay.
So and you know what? Yes. Remember how we've been working with the quadratic equations, and it always looks
Yeah.
like, I'm going to make up a quick example. Maybe it looks like this: 5x squared minus 3x plus 10.
Hmm.
The 5, negative 3, and 10, that's our A, B, and C.
Oh, okay.
Is that okay?
Yeah, that makes sense.
And if one of these numbers is negative, like my 3 is in this mini example, I'm going to say example, make sure that negative goes with your letter, okay? So if we're plugging in things, if we're plugging in A, B, and C into the formula above, bring those negatives along for the ride. They're not static. They don't stay behind. Um, I'll show you what I mean right now if we're ready. If we're ready to see one.
Yeah, I'm ready.
Braden, thank you for asking. That was a good job.
Hmm.
I'm really happy whenever someone is willing to tell me where they're coming from and tell me if they have a question. I want to work it out with you. Here we go. Let's try example 1. So example 1. Remember, all of our problems in this unit, they're giving you some quadratic equation, just like this. So here's example 1 I'm ready with. 3x squared plus 4x minus 12 equals 13. So at first glance, it looks like A is 3, B is positive 4, and C is negative 12. However, it's not solved for 0, is it? It's equals 13. So our first step is a little bit of like preliminary background work. We got to put that 13 where it ought to be. We have to solve it for 0 instead of 13. So instead of equals 13, I'm going to subtract both sides by 13, like so. And we're left with 3x squared plus 4x. And now we've got negative 12 combined with negative 13. They're both negative. It's kind of like if I were doing it next to each other instead of under each other like it is there. It would be like this: negative 12 minus 13. Okay, those are going to combine to negative 25 equals 0. Okay, so here's our actual starting problem. And like Braden said a moment ago, this is where the A, B, and C are coming from. So my A is 3, B is 4, and then C, check it out, it's negative, so C is negative 25. Okay, so those are the only things we need. We're going to take those numbers and plug them into our quadratic formula. So here we go. Quadratic formula, I'll start on the left side of my screen so I have space. So x is, remember, x is the solution, right? So x is equal to negative b. So that's negative. You know what? Since it's our first time, I'm going to write it again blank. Okay, I'm going to write it again with a, b's, and c's. So here we go. Negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a, 2 times a. So there's the blank version. Now let's plug in our parts. So I'm going to write it again. X is equal to negative 4 plus or minus 4 squared minus 4 times 3, that's a, times negative 25. And then all divided by 2 times a, which is 2 times 3. Okay, I'm going to wait a second while I'm hoping you guys are taking notes and trying to follow along with me so you have some examples. I'm going to wait while you're catching up. And then we'll start like simplifying it one step at a time and finding our answer. Okay.
I have a question.
Yes, sir.
Why are we dividing it by 2 times 3?
Because it's because it's built into the formula. Look above where I'm going to make purple real quick. Make purple. So I can distinguish what I'm doing. So right here in the purple box, here's our blank generic quadratic formula again, just from the last page. Okay, this is our shortcut to go straight to the solutions. X equals this mess. So see in the bottom of the fraction, 2 times a.
Oh, so okay, so we just took 2 and then now we're timesing it by a, which is also 3.
Correct.
Okay.
So in the formula, good, Braden. In the formula, there's a couple numbers already in there that'll be there every time. In the bottom, like Braden's pointing out, it's 2 times a. Inside the square root, we've got b being squared, okay? That's not times 2. That's b squared above. Notice that. And then it's minus 4 times a and c. Okay, so those numbers are going to pop up each time. It's b squared is there all the time. And then minus 4 is there. And then in the bottom of the fraction, 2 times a. Good question. And now let's start taking this apart and simplifying it, making it smaller. I hope that bar thing is not in people's way. I don't think it is. I hope not. Move it out of my way. There we go. Okay, so continuing below. Remember back in, we haven't done too much of this in this class. I haven't spent a lot of time on it, but remember PEMDAS from back in the day? PEMDAS. I'm going to put it on the right side. This is our order of operations. This is the order we should go about doing things when we're like simplifying math problems. Parentheses, exponents, and then multiplying and dividing, and then adding and subtracting. Basically, start at the top and go down. We want to always do parentheses if there are any. We want to then do exponents if there are any. And then we do the multiplying and dividing, and then we do the finally end with like adding and subtracting. Now, this is a little more complicated because we've got like the square root box. We need to take care of the stuff inside the square root box kind of on its own. And then once that's as simplified as possible, we'll like interact it with the negative 4 plus or minus, and then the dividing by 2 times 3. So let's deal with the inside of that square root box. For our purposes, that's kind of like a parentheses. It's a bundle of of work, okay? So we're going to simplify what's inside that square root box using PEMDAS. Here we go. So I'm just going to recopy down the stuff I'm not really concerned with yet. So -4 plus or minus, that's still there. Square root box. We'll get to that in a second. In the bottom, we can go ahead and do the multiplication now. That's not going to mess anything up. 2 times 3 at the bottom, that's 6. Let's just get that done now. Okay, now inside my square root box, 4 squared. Someone tell me, what is 4 squared? 4 times itself.
16.
16. So I'm going to replace that right now. 16 minus, here we go. I've got minus 4 times 3 times -25. Help me out. Leja help with I think that was Leja help with the last one. Someone else give me this. 4 times 3 times 25.
Is that 300?
I'm going to trust you. 300. 4 times 3 times 25.
Wait, I did that in my head. Don't trust me.
No, trust him. He's right.
Leja, Braden, good team. Thank you both. So we'll say 300. Now, one other thing, folks. Notice it's minus all like the multiplication, right? Minus the 4, 3. And 25 is negative, right? So here we're having negative times a negative. So it's going to turn into a plus 300, okay? Multiply the numbers and then worry about the negative signs. If there's 2 negatives, it's going to turn positive. If there's a single negative or if there's like 3 negatives, it'll stay negative, okay? Anytime you've got negative times a negative, it becomes positive. So now we have, reading the whole deal, -4 plus minus square root of 16 plus 300 all over 6. Okay, continuing right here. X equals -4, oops, whatever, -4 plus minus. Let's add inside there. So 16 plus 300, now it's just 316. Woohoo! And it's over 6. Okay, now try in your calculators, on your phone, on the computer, or in a real calculator, whatever you have. Try doing the square root. See if you get a clean answer. It not always will be. 316 square root. Okay, I got 17.776, this terrible decimal. We don't leave our answers in decimal when we're working with precise quadratic answers like this. We want the precise answer. So now I'm forgetting if we've done this as a group. I'm pretty sure we have, and I wish I would have known for sure. We're going to do a little bit of, yeah, we did this as a group at some unit 1 or 2. We have to break down this root 316 a little bit. So side work on my right here, okay? Root 316. Remember when we were simplifying complicated square roots? I think it was unit 1. Let's see if we can get any number out of that 316. So I'm going to do a factor tree for 316. It's funny, that's a famous Bible verse, John 3:16. I'm going to do a factor tree for this number and see if I can like simplify and get some of that reduced kind of outside of the square root box. Okay, so just as a refresher, we haven't done this in a while. 316, divide that by 2. So it's 2 times 158. Okay, now break down that 158. Divide that by 2. Okay, it's 2 times 79. 2 times 79. Okay, so because I've got 2 times 2, that's going to simplify outside of the square root box. Can the 79 break down? I'm not sure. Maybe it won't. Let's try some things. 79 divided by 2? No. 79 divided by 3? No. 79 divided by 4? No. 5 won't work. 6 won't work. 7? No. 79 divided by 8? I'm just kind of going down the list, trying to divide 79 by whole numbers until I get a hit, until I get something, until I get a factor of whole numbers. And I think maybe we can stop there. 79 turns out to be a prime, so we're done. So basically, there's no more factoring to do. So what's happening here is we've got 316, root 316, and it's really 2 times 2 times 79. Okay, it's really these things at the end of the factor tree multiplied. So it's 2 squared times 79. Now, remember how square rooting cancels squaring? So root 2, square root of root 2, square root of 79. The square root and the squaring on the 2 are canceling. And the 79 is trapped inside. It doesn't get to come out because it would need another 79, okay, to cancel. Doesn't have it though, right? So we're done simplifying. So 2 root 79. Okay. Should have made that a warm up. I forgot that we were going to be doing more factor trees potentially for these problems. Okay, any questions before I move on and go back to our actual like quadratic formula? Anything at all, please.
Well, I mean, why did the square roots cancel each other?
Why? Good question. Okay, good question. Why do square roots cancel each other? Or the squaring and the square root is what you mean, I think. Yes. Why do
Yes.
squaring and square roots? I'm glad you asked. Cancel each other. Okay, because remember back in Unit 1 when we did all the different exponent rules, and we also did the fraction exponent rules. So let's say we had this, x to the 1/2 power. So if you remember back to Unit 1 and our work we did with fraction exponents, the 1/2 power is defined as like the second root of x. I got all these people in the waiting room. Hang on. I thought I let her in. So I'm hoping this. I know it's we haven't used it in a while, so I don't blame anyone for forgetting about it. But I'm hoping it just rings a bell, and you remember seeing this before with me this year. The fraction exponent is defined as moving it into a the second root, and then for example, if we had other fraction exponents, just for example, let's say we had x to the a over b. Those are just numbers. The a over b fraction exponent. So that turns into the b root of x to the a. Okay. So what I'm doing is I'm mixing together this older idea that we used before with simplifying our work today in the quadratic formula. So because I can convert fraction exponents to square roots, when I'm dealing with actual problems now, like for example, let's say we had 5 squared, and I'm taking the square root of that. Okay, so here's an example problem to demonstrate. I want to do the square root of 5 squared. Well, 5 squared is 25, right? And you also probably remember, because that's a low number, the square root of 25 is 5. So let's see what happens with the math rules when we clean this up and simplify it. So using the definition above, the square root can be rewritten as this. So instead of square root of 5 squared, it's the 1/2 power. Okay, I'm just converting the square root box to the 1/2 power based on that definition from earlier in Unit 1. And now, remember the other rule, we've got a power to a power. The second power raised to the half power. You remember, we multiply power to a power together when it's written like this. And that converts to 5 to the 2 over 2 power. But wait a minute, 2 divided by 2 is 1. So this is 5 to the 1. And remember, the first power, 1 power like this, it just means the base, 5. So the point is, it's this rule right here. It's the definition, it's right here, that the square root of something is the half power. And if I've got 5 squared and it's raised to the half power, the canceling is happening when 1/2 gets multiplied to the 2 power right here. And of course, 2 over 2 is just 1. It cancels out. I'm probably talking too much and maybe didn't get to the point. Leja, and all of you, whenever we have square root of something squared, it's almost like by definition, in the same way that, let me show you this, adding and subtracting are opposites. I can't spell subtracting. Okay, so opposite operations, right? The operations we do to like solve an equation. So adding and subtracting are opposites, multiplying and dividing are opposites. And then also, you don't learn about these when we're really young, we learn about them now. Squaring and square rooting. Square rooting are also opposite operations. So they're always going to cancel each other. And to get into like why it works, we have to use all those exponent rules. Because looking over on my little x example again, I can rewrite that as x squared to the half power. Those are equal based on the definition of fraction exponents. And then we multiply that in, we get x to the 2 over 2, and of course 2 over 2 is 1, and of course that's just x. So that's the reason why it works. And then just going forward, feel free to treat it as like what I've got on the right side. Squaring, square rooting, always cancel each other out. So if you can rewrite something as a number squared and you're taking the square root, all you're left with is the base. I hope I didn't lose you, Leja.
Oh no, I'm sorry. Just for a second, I thought my mic was like unmuted, but it wasn't. I was gonna tell you that I caught it like the first time.
Oh, for sure. Okay, good. Okay, I'm
Thank
glad.
you.
You feel better about it or not really? Honestly speaking?
Yeah, yeah.
Okay.
No, I feel better about it.
I'm afraid I might have gone on too much of a tangent, a rant, and lost people. Okay, I hope that was. Thank you, Leja. I hope you're doing okay. I hope everyone else is too. Any other questions on this? On why that works? On why squaring and square roots cancel each other? For what it's worth, feel free. I know it might be a new idea, relative in your lives, because we haven't been doing it since we're little, like we did with adding and subtracting, multiplying and dividing, but squaring and square rooting will always cancel by definition. So that's why we had to do this business over here. We want to simplify the root of 316 and get out as much number as we can. We want to make it smaller inside there. And that's what I did here, was make it 2 root 79. Okay, so back to the quadratic. So back to that original example we were doing, folks. We have -4 plus minus. Now it's not root 316, it's 2 root 79. And it's over 6. Okay. And now there's a little bit of simplifying we can do left, and we'll show both of our solutions, and we are done. I'm going to go to a clean screen, but it's the same problem. So just picking up where we left off. Okay. So remember, the plus minus symbol, plus minus, that is symbolizing that we have two different answers, okay? It's 4 plus and it's 4 minus. So I'm going to go ahead and show both of those now. So this weird symbol, I'm going to branch that off into its actual two meanings. So we have x is 4 plus 2 root 79 over 6, and x is 4 minus 2 root 79 over 6. There's the two solutions. Now, check this out, because 4 and 2 are being divided by 6, We're going to clean this fraction up a little bit, and then we'll finally be done. So to clean this up, I'm going to split up and then divide and reduce those fractions separately, basically. So on the left, I've got my 4 plus version. On the right, I have my 4 minus version, and I'm splitting up the fraction. Check those out. The only difference is a plus and then a minus on left and right. Okay, so 4 6, if I divide each of those in half, I get 2/3. 2 6 turns into a 1/3. And on the right, it's the same thing we just did, but negative instead of positive. So it's, 2/3 minus root 79 over 3. And holy cow, we did it. So I think I'm just wondering if the biggest challenge using the quadratic formula is probably going to be simplifying those square roots, simplifying the radical. The root of 316 turned into 2 root 79. I could be wrong, but I'm thinking that might be the biggest challenge here. I'm going to wait a moment while people are still writing, and then we'll try another example. Now, as confusing as the quadratic formula may seem, it's kind of nice. The benefit of it is that it takes us straight to the answer. It takes us straight to the two solutions. It's just a whole lot of algebra, right? It's a whole bunch of like simplifying. But as soon as we feel comfortable with that, this is actually kind of easier, I think, in a way, than doing all the factoring, making lists and factoring. Okay, here we go. Let's try another one. Example 2. Okay, let's try this. Negative 2x squared minus 5x plus 11 equals 0. Okay, we're ready to start because it's equals 0. We don't want to start the quadratic formula until it says equals 0. So unlike the last example, we're ready to start right away. A is negative 2 because of this right here. B is negative 5. And C is positive 11. And this time I'm not going to show the blank version. You should have it at least twice on your pages. So I'm going to start plugging these in right away. Okay, x is equal to negative b. Notice that b itself is negative already. We're going to clean that up in a minute. What we have is negative b, which is negative negative 5. And that'll simplify, but I'll do that in the next step. Plus or minus square root of b squared, so that's going to be negative 5 squared, minus 4 times a, that's negative 2, times c, which is 11. All divided by 2 times a, which is 2 times negative 2. Okay, I'm going to wait a moment while you're writing. So I didn't do any simplifying. I just plugged in all the a, b, and c's, where they go, and that's why we see so many negative signs. But next, we're going to clean those up. Here we go. X equals. Here's my big fraction bar, and I'll start putting stuff in. Here's our plus minus. Let's do that. And here's our square root. Now let's do the different zones, right? On the left, we have our negative b. Negative, negative 5, well, that's positive 5. Negative times a negative makes a positive. That outside negative is like negating whatever's inside there. So that we end up with that double negative and it turns positive. Plus or minus square root Negative 5 squared, remember, if you square a negative number, that's like negative times negative. So again, this is positive. That'll always be positive because you're squaring it. Then we have 4 times 2 times 11. So in your calculator, you're going to do what? 8 times 11, 88. 4 times 2 times 11. And then notice that we have negative, negative. Negative 4 times negative 2. So that's going to turn into plus, just like last time. So we have plus 88. I'm going to stop. Any questions so far? No questions. Okay. So in the bottom, we're almost done with that. 2 times negative 2 should give us a negative 4. So here's where we're at so far. Let's clean up inside the square root box, and then we'll have to probably reduce it like we did last time. So get ready. So we have 5 plus or minus square root 25 plus 88, 113. Sweet. And then it's divided by negative 4. Okay, so I'm going to change my color to differentiate what's going on. And on the right side, we're going to do our side work to break down that 113, or try to. It won't always break down, but often it will. So here's some side work. We want to reduce the square root of 113 as much as we can. We want to get as much out of the square root box as we can. So 113 factor tree. Let's see, I can't divide that by 2. It's not even, right? So I can't divide it by 2. Divide it by 3 doesn't work. 4 doesn't work. 5 didn't work. 7 didn't work. I don't think it's going to work at all. So how do we know when we can stop? I've gone through the list and I was dividing 113 by 2, 3, 4, 5, 6, 7, 8, all the way up. How do you know when to stop? Take the actual square root of the number. Okay, the square root of 113 was 10 and change, 10.630. Once you get to 10 through dividing and you still haven't gotten a hit, that means it's a prime number and you can just stop. So since nothing worked for dividing 113, it turns out 113 is prime. And we actually can't reduce or clean this up at all. So we're stuck with the 113. It's kind of good. We don't have to deal with doing more of that for this example. So we are done. We're done with this example. Continuing over here to show both of them, I'm going to split it up into the plus and the minus version. So what I'm referring to is 5 plus square root and 5 minus square root. So our two solutions are x equals 5 plus square root of 13 over 4, over negative 4, and x is equal to 5 minus square root of 113 over negative 4. And we are done. There's no need to split it up, I don't think, in this case, like I did for the last one, and do like 5/4 plus square root 113 fourths, because we're not going to reduce those fractions, because 5/4 doesn't reduce. And the only other thing is if either the top or the bottom of a fraction is negative, like these are, the negative 4, it's more customary to make the whole thing negative instead of showing just the bottom, just the denominator. So I'm going to write it this way. So it's negative 5 plus root 13 over 4, and then it's negative 5 minus root 113 over 4. And there's our answers. Remember, just to tie this together with what we used to do with graphing, the solutions that we're finding, these numbers, as crazy as they're looking right now, remember what they stand for? X equals x equals. That's where the parabola is crossing the x-axis. So just for kicks, I want to see where that is. It's going to be a decimal, so it won't be precise. But 113 is 10.630, all that stuff. So I'm going to plus 5 and then divide by 4. So this first solution, where'd it go? The first solution is like roughly, because I'm going to round it, right? I'm rounding a decimal, so it's not precise, but it's approximate, negative 3.91. And the other one, square root of 113. And this time it's 5 minus, and then it's divided by 4. Okay, and the other one is negative 1.41. Okay, so the point is that at those locations, that's where our parabola is crossing over. So just so this kind of hopefully makes a little more sense and ties together. So here's negative 1, negative 2, negative 3, negative 4. If we were graphing this thing at 3.9, so almost at 4 right here, and at negative 1.4, which is about in between those. So that's where this thing is crossing over.
Okay, so when you put the answer,
Yeah.
is that a negative next to it?
It is, yeah,
Okay.
it is.
So is that why the 4 is not negative
Correct.
anymore?
Yeah, I'm basically correct, David. I'm taking that negative from the 4 and making the whole value, the whole fraction is negative.
Okay.
Good. So you're going to see that in Admentum. You won't see answers with like a negative in the bottom. The whole fraction would be. So if you work it out and you get like we did, negative 4 in the denominators, what you're going to see in Admentum is the whole fraction, like I wrote it at the very end. Okay, it's 10:42 or later than that actually. I'm going to do one more. I'm going to just do one more. You're going to see some in Admentum that don't start ready. So our example 3, what I mean is they don't start ready to begin. We have to do a little bit of cleaning up and make it into ABC form. So for example, what if it starts like this? Solve this quadratic, they call it, for its solutions. But it doesn't even look like a quadratic. X times negative 2x minus 11 equals negative 3. This doesn't look like a quadratic. But if we multiply and solve it for 0, it will look like a quadratic. So remember, we're just doing distribution. We're bringing that x inside. We're multiplying it to everything. We get negative 2x squared. X times x makes it x squared. And then x times negative 11 is negative 11x. And that is equal to negative 3. We want it to be equal to 0. So I'm going to add 3 to both sides. So we get plus 3 equals 0. And now we're ready to start. So don't be too freaked out if you're given something how it started here. A little bit of work, and we've got it ready to start. A is negative 2, B is negative 11, and C is 3. All right. X is negative B, which is negative 11. Look out for those double negatives. B squared is negative 11 squared minus 4 times negative 2, that's A, times 3, 4AC. and then divided by 2a. So that's 2 times negative 2. That's dumb. It's another negative 4 on the bottom. Okay. Always deal with the inside of the square root first. And you can clean up like the negative 11 and the 2 times 2 in the bottom separately. So let's do that. So negative 11, that's positive 11. In the bottom, 2 times negative 2, there's our negative 4 again, like last time. And that's just because we happen to have the same a number, okay? It won't always be that. All right, now, negative 11 squared. That's going to be positive 1 something, 121. Positive 121. Okay, then minus 4 times 2 times 3, negative 4 and negative 2 multiplied together makes that a positive. So we get 24. And that 24 is 4 times 2 times 3. Okay, not too bad. Let's continue. So we have 11 plus or minus. 121 plus 24 is 45. So 145. Square root of 145 over negative 4. Okay, let's try cleaning up the root 145. Okay, so in purple, I'm going to clean that up on the right side. 145. Try breaking it down. It has a 5 at the end, so that means I could divide it by 5. 5 and 29. Okay. Good news for us again is that since 29 is prime, meaning it can't be broken down, it's just 1 and 29. That means we can't reduce or clean up square root of 145. So we've solved it. We're basically done. Our two solutions is going to be x equals negative 11 plus root 145 over 4, and x equals negative. Now, where's that coming from? It's because the denominator is negative 4. So I'm bringing that out to make the whole value negative. 11 minus root 145 over 4.
Josiah, I kind of have like a question.
Yes.
Why is the 5 and 29 not being used?
Because I'm going to move away from the screen. Because remember, we want to find things being squared. Remember how you asked earlier about squaring and square rooting canceling. So our goal is to make 145 into something like, for example, I'm not going to say, well, I'm not going to use a either. We want it to be numbers being squared. Like if I could rewrite 145 as j squared times, k, then the j squared would become this. J on the outside times root k. We're looking to turn 145 into like smaller components that are being squared so that they can cancel and get out of that square root box. However, when I try it with the number 145, I start dividing, right? I know I can divide it by 5. 5 times 29. Then we start trying to break 29 down. Ideally, it would be 5 times something, right? So that way we would have a pair of 5s, and then that would get to come out like the J did on the right side. But it doesn't work. When I tried dividing 29 by different smaller values, so 29 divided by 2 doesn't work. 29 divided by 3 doesn't work. By 4 doesn't work. And if you keep going, you're going to find that they're all decimals. It's a prime number. It doesn't break down. Just like 5 doesn't break down further. 5 is also prime. When we make our factor trees, we're always going to the end of the root system where we get to primes. So 2, 3, 5, 7, 11, those are prime numbers where they don't break down through multiplication any further.
Okay, I think I get it.
Does that help?
Yeah.
29 is prime. I don't expect you guys to remember that.
Mhm.
But when we're trying to break down a number like 29, just kind of do guess and check. That's what I'm doing. I do 29 divided by, everything until I convince myself it's prime. The one thing we can do to be strategic is take the square root of 29, and it's 5.3 and change. And so basically, you only need to check 29 divided by all the numbers up through 5. Once you get to 5.3 and go past that, we don't have to check any further because we've already divided those already. Kind of like how when we're making our lists, we get to the middle of the list and we don't have to go further because we're getting repeats. So to make it simple, just divide 29 by everything, whole numbers that are small, starting at 2,
Mhm.
moving up. If you don't ever get a hit, it's prime.
Okay.
The big prime numbers are all going to look weird, like 29. I don't know. It's kind of an ugly number to me. And then, and no offense. I'm sorry, everybody. I hope no one was born on the 29th and I just offended you. The larger prime numbers are like 29, 31, another,
37.
37, good. And honestly, this is kind of a fun topic. In college, I learned that there's an infinite number of primes, and I think someone proved that there's more prime numbers than there are non-prime numbers, which is weird, which doesn't make sense.
That's kind of cool.
Yeah, it's
Do you
kind of
remember how
cool.
they proved it?
Yeah, I can't prove it anymore. I did it because I had to in college because I was like, it's an assignment, but and now I've completely forgotten how to do it.
No, that's crazy. I didn't think that was really possible.
Yeah, there's infinities that are larger than other infinities, and so there's like an infinite number of non-prime numbers. But I think someone proved that there's more prime numbers than there are non-prime numbers, which is weird. It doesn't seem right.
It feels like now I want to look it up and just settle my mind because I'm just gonna be thinking about it. There's an infinite number of non-prime numbers.
If we
Crazy.
can, I think we're on track to finish our class a little earlier than my Math 1 class. So if we do, then, and we're done with the first 5 units, we'll have a special day for anyone who wants to come, probably just me and Leja, and we can talk about primes and we'll play with those, and I'll show you what I can find about that. I'd love to do that with you guys. That's like the fun stuff. All right.
You guys definitely join. It is the fun stuff.
It is the fun stuff. So maybe I'll make it mandatory. Mandatory fun.
You said we're on track to finish early.
Yeah, we're on track to finish early.
Oh wow.
So I'm pushing you guys a little too hard, I guess. We're finishing early.
Well, it's actually all going pretty smoothly for you pushing us.
Good. Yeah, we're on unit 4 and we're going to finish next week. And in Math 1, we're just starting unit 3.
So how do you remember all this stuff? Like, as the math teacher, do you review too, or do you just remember all these
Yeah.
concepts?
Oh, I absolutely, I review.
It seems so random, but you're just popping it out and then just doing it.
Right? It's like it's like you memorize this. And it's just in your head forever. I can't. My memory's so bad.
Honestly,
Right.
it's because it's like muscle memory. It's because I've taught for 4 years now, or 5. I guess this is my 5th year. So, I've done these same concepts, and I kind of learned how I like to do it, and then I'll remember most of it. Honestly, I remember this quadratic formula, even though you're probably thinking, "What's wrong with you? How could you memorize this?" Yeah, so I memorized this quadratic formula. I mean, it's good to double check, make sure I'm not missing something. But for instance, I should have reviewed more. I did review this morning to go over how I wanted to present this to you guys. I should have reviewed a little deeper because I forgot that we'd probably have to do breaking down square roots. And that's kind of a big subtopic. That's a lot to remember and to expect all you guys to remember how to do. So I should have made that into a warm up.
I know it seems like everything that was presented, like you planned for it. Like this is how you wanted it to go. You know, it seems so precise.
Perfect.
Right.
It's a perfect show then.
Yeah.
Meaning like it looks like I planned it when I didn't. So that's a win. No, I totally prepared. I had the problems ready to go. And I wanted to show you a couple different cases. One where it's starting not equal to 0, because that'll come up. And then an easier one, like where it is starting equal to 0. Yay. And then one that looks like this, nothing like a quadratic. I just want to prepare you for like the different cases that we could see.
Have you ever forgotten something and you got nervous because you're about to teach a class?
Of course.
Oh, really?
And it sucks when you're in the middle of the class and someone asks a great question and I'm like, oh, Josiah,
Darn.
now you look like a fool. So here's how I handle that. I am honest and I say, you know what? I don't remember that. And I'm going to look that up later. Oh yeah. And I'm going to look that up and get back to you tomorrow and we'll talk about it. But
That's cool. Being a teacher is cool, guys. Like, I don't know, if I forget a question, I'd be like, well, we're wrapping up class, guys. I'll be back in like an hour.
Yeah. Everyone go home. I quit. Yeah, totally. No, it feels like the desire to do that is there for sure. Because it's like I want to hide. Oh no, I'm turning red and I can't remember what it is they're asking. So yeah, it's awkward.
No, being a teacher, I never thought like, oh yeah, being a teacher, it's easy. They know everything. And these go to them, they just know the answer. No, teachers are human. They're just like us. They forget everything like we do too.
You got it. And then the more you do something, the more you start to remember the little things like the quadratic formula, like since I enjoy it and I do it every year, a couple times I remember it.
Yeah.
And you guys will too. Like I remember how to change oil in my car just because I've done it a million times. But the first few times, my dad taught me, and guess what? I made some mistakes when I did it on my own. But then you do it a bunch of times, and you just start to remember how.
Yeah.
Let's see. I thought Bailey was here, but she's gone now. I'm gonna say she was here but left early. Aaron's here. Delaney's here. Janessa. I don't see. Keegan is here. Braden and Maria Celeste. Yay! Everyone's here except for just like 2 people. All right, folks. I hope you're doing well. Have a wonderful weekend and a safe weekend, and I will see you again on Monday.
Thank you, Josiah. Have a wonderful
Have a
day.
good day.
You too.